video lecture series of Grade 10 Chemistry. Today we will discuss Grade 10 previous year questions for Chapter 4 Carbon and its compounds. So here the first question is, explain why carbon forms compound only by covalent bonds, and also explain in brief two main reasons for carbon forming large number of compounds. Why does carbon form strong bonds with the most other elements? This question is asked in 2023. So we can have a look at the answer. So explain why carbon forms mainly by covalent bonds. Because carbon is tetravalent. Tetravalent means carbon's valency is 4. So it has 4 electrons in the outermost shell. To complete the octet, it needs 4 electrons. Thus, it can either gain or lose 4 electrons. But losing or gaining 4 electrons is not possible due to energy consideration. Hence, in place of gaining or losing 4 electrons, carbon does share these 4 electrons and forms covalent bonds. Okay, and why carbon forming large number of compounds? This is because of two reasons. The first is catenation, okay, and second reason is tetravalency. What is catenation? Catenation is the tendency of carbon to form long chains. Okay, it can form ring chain compounds, straight chain compounds, and branched chain compounds. So this self-linking capacity, this is called a self-linking capacity. The self-linking capacity of carbon is called a catenation. Okay, and then second one is tetravalency. Carbon has 4 electrons, as you know. So it can form 4 covalent bonds with the 4 different atoms. This 4 covalent bond can be single bond, double bond, or triple bond. And they can form strong bonds with most of the other elements like hydrogen, oxygen, sulfur, nitrogen, chlorine, bromine, iodine, etc. Also, the small size of carbon helps to attract more number of electrons. Okay. Now, the second question. Why is acidified water considered to be a good conductor of electricity? What is the answer? When acids are added to water, hydrogen ions are created. H plus ions are created. Okay, so the acidified water is a good conductor of electricity because of the presence of these ions. When ions are there in the water, electricity can be conduct very well. So when you add acid into water, hydrogen H plus ions are produced. Then, second question, write a chemical equation showing the ionic products formed on dissolving potassium hydroxide in water. So potassium hydroxide formula is KOH. When it dissolve in water, KOH plus H2O, the products are K plus potassium ions and OH minus ion. Potassium forms a cation and hydroxyl ion. This is a negative ion. So a cation and an anion is formed when potassium hydroxide dissolves in water. Now, third question. Care must be taken while diluting concentrated nitric acid with water. Why? This is because it's an exothermic reaction when this acid or when an acid or base dissolves in water. Mixing of concentrated nitric acid with water requires caution. Always you need to slow when you add acid into water, and you should stir it constantly because it's an exothermic reaction. So much heat is produced. Okay, and the heat produced when water is added to concentrated acid can cause a mixture to splash out and hurt people's burns. So, additionally, excessive local heating could cause the glass container to shatter. So, when you dilute any acid, any concentrated acid, it should be slow, and you have to add slowly the acid into water, and constantly you have to stir the solution by using a glass rod. Okay? So, care must be taken while diluting concentrated HNO3. And this question is asked in 2023. Now next question. what is a homologous series of carbon compounds? Write general formula for alkynes. Then name and draw the electron dot structure of first homolog of the series. So homologous series is a series which contain, they will have a general formula, okay, that they differ only in the carbon chain length. Compounds in homologous series often have a fixed set of functional groups resulting in chemical and physical properties that are comparable. For example, in homologous series, the important points you need to note that they will have a general formula, okay, and the preceding and succeeding member will be differ by a CH2 group. Then their physical property will be different because they have different carbon chain length, okay. Physical property will be different. Physical property different, but they will have same chemical property. So their chemical property will be same. And for alkyne series, the general formula is CnH2n minus 2, okay, CnH2n minus 2. So this is the general formula for alkyne series. Name and draw the electron dot structure of first homolog of the series. So in alkyne, the first member is ethyne, okay. If you are taking alkane, the first member will be methane, CH4, and then its electron dot structure will be carbon. There will be 4 hydrogen atoms around carbon because carbon has valency 4, okay. So you should draw 4 electrons around carbon, and for hydrogen you need 1 electron, and carbon will be sharing all these 4 electrons with the hydrogen's 1 electron and acquire an octet. Similarly, hydrogen will acquire 2 electrons each. Okay, so this is the electron dot structure of methane. And for ethane, it will be C2H6. So there are 2 carbon atoms, and this will be sharing electrons with the hydrogen atom. Okay. Now, but in the case of alkyne series, CnH2n minus 2, as you know, alkynes will have CnH2n minus 2. So this is alkyne. Okay. So the first member, we don't have any n is equal to 1 member is not possible in this case. We'll start with n is equal to 2. So C2H2 into 2 minus 2, which is equal to C2, 4 minus 2, that is 2. So C2H2. So there are 2 carbon and 2 hydrogen, and these 2 carbon atoms share a triple bond. The hydrogen is a single bond. Carbon hydrogen bond is a single bond. So triple bond means they are sharing 3 electrons. So you should draw 3 electrons around this one carbon, and second carbon also sharing 3 electrons, okay, and the hydrogen atom sharing 1 electron with this carbon. So what you have to notice in this particular structure is that triple bond around each carbon means they are sharing 3 electrons. So around this carbon we have to satisfy 8 electron condition. So 6 plus 2 8, and second carbon also you should draw this 6 electrons together and these 2 electrons. So this is the electron dot structure of 2 carbon atom, and this hydrogen separately you have to draw a diagram in this way. Okay, now this is the electron dot structure of the first member in the alkyne series. Its name is ethyne, 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 or general name is acetylene, ethyne or acetylene. And so this is electron structure. If you wanted to write the homologous series of this member, the second member will be N is equal to 3. So the formula is C3H 2 into 3, 6, 6 minus 2, that is 4. C3H4. So there are 3 carbon atoms, and one of this carbon will share a triple bond. Remaining, the fourth valency will be satisfied with this hydrogen. So in this middle carbon, you don't want to draw any hydrogen because the 4 valencies are already satisfied. And the last carbon, I mean the third carbon, you need to draw 3 hydrogen. Okay, and this member is propyne because it will contain 3 carbon atoms. So 3 carbon skeleton we say prop. That is a parent name. So prop plus YNE, so it's called propyne. Now, the next question. State the meaning of functional group in an organic compound. Write the formula of the functional group present in alcohols and carboxylic acid. What is a functional group? Functional group is defined as an atom which makes carbon compounds reactive and also decide the various properties of the compounds. It contains a heteroatom. When this heteroatom is attached to carbon, okay, the carbon will get different properties. So the formula of the functional group for alcohols and carboxylic acids are alcohols we say OH group, okay. So OH, this is called a hydroxyl group. So generally we can write ROH. R represents alkyl group and OH represents the hydroxyl group. Carboxylic acid, the functional group is COOH. General formula we can write in this way RCOOH. Okay. So OH is the functional group of alcohols and COOH group is the functional group of carboxylic acids. Now, next question. Draw the structural isomers of butane. Okay, structural isomers of butane. In the sense, you already know what is an isomer. Isomers will have same general formula. Okay, they will have same general formula, but their structure will be different. So they will have different structure. Okay, so the first question we are going to draw the structural isomers of butane. Butane will have 4 carbon atoms. So its formula is C4H10. C4H10. So there are 4 carbon atoms. So first of all, you have to draw all the 4 carbon in a straight chain manner. Then put hydrogen atoms. So this will be written in this way: CH3, CH2, CH2, CH3. All the carbon atoms and hydrogen atoms are writing in a straight chain manner. So we call this as normal butane or N-butane. N-butane. It's called a normal butane. Now, so this is the first isomer, first structural isomer of butane. So in order to write the second isomer, what we have to do? We should reduce the length of the carbon chain. Before we have 4 carbon atoms in a straight chain manner. Now we will be reducing this into 3 carbon atoms. Which means that 1, 2, 3 carbon we will be writing in a straight chain manner and the fourth one will be substituted in the second carbon. Okay. So 1, 2, 3 and this is the fourth carbon. So this is the second isomer of butane. Okay. Then you have to add hydrogen atoms accordingly. So here 3 hydrogen, CH3 and then second carbon also you have to add hydrogen atoms. I will write this in a separate page. Okay. Now, see. 1, 2, 3. This is the fourth one. So the first carbon, you need to add hydrogen in this way. This is CH3. When you look at the second carbon, this carbon, already 3 valencies are satisfied. So fourth valency, you add only 1 hydrogen. And the third carbon, we will have 3 hydrogen atoms you have to add. And the last carbon, which is a substituted carbon in the second one, add 3 hydrogen again. CH3, CH, CH3. Then second carbon, you have the branch CH3. If you reduce it, it will be looking in this way. CH3, CH. Here you have the substitution CH3, and this one is CH3. CH3. Okay. Now, next question. Name the the second one. Draw the structure of propanol and propanol. Okay. Propanol. Propanol means actually it's an alcohol in which first carbon is methanol, second carbon alcohol is ethanol, and third one is propanol. Okay. So propanol. CH3, 1, 2, 3 carbon. Okay. And then you have to add one OH group. So this is propanol, and you have to add hydrogen CH3. Here it is CH2, CH2. This is propanol. And for propanol, this is a ketone actually. So central carbon you should have a double bond. Oh, this is called keto group. CO group is called keto group. So, around these two carbon you should add hydrogen. So CH3, CO, CH3. This is called propanol. Now, the next question, name the third homologue of alcohols and aldehyde. So what is the next homologue of third homologue of alcohol and aldehyde? Alcohol, we already know the first member is CH3OH. In the case of alcohol, the first member is CH3OH. So this is the first member. How do we get the second member? You should add one CH2 group. So CH3, CH2OH. This is second member. Then third member, you should add one more CH2 group. CH2OH. This is the third member. This one is called propanol. Third member is propanol. Okay. Now propanol. Propanol is an aldehyde. Al means an aldehyde. Okay. So aldehyde. When you write aldehyde, you should be very careful because we are not starting with any alkyl group in the aldehyde. Even though the formula starts with RCHO, the first member is HCHO. This is the first member. Okay. This is called methanol. Second member, you should add a CH2 group to this hydrogen. So the member will be, second member will be CH3, CHO. This is called ethanol. And the third one, again you have to add one more CH2 group. Then it will become CH3, CH2, CHO. This is called a propanol. Okay. Now, next question. Name the following. Okay. This compound is having, I'm talking about the fourth question. Name the following. So CH, C double bond. Okay. So there are 1, 2, 3, 4, 5, 6 carbon. So there are 6 carbon. And how many hydrogen? Hydrogen also 6. So this compound is benzene. So its formula will be C6H6. And second one, it will have a double bond. So 1, 2, 3, 4. You should start counting from the double bond. Okay. So 1, 2, 3, 4 carbon atom compound is bute. Okay. So that is butene because it will have a double bond. So butene. If you wanted to write the double bond position, you can write it as 1-butene because this 1 represents the position of the double bond in the first carbon. Or you can write in this way, but1-ene. Both are same. So the compound is butene, 1-butene. 1 represents that the double bond is coming in the first carbon. Now the last question is show the covalent bond formation in nitrogen molecule. So nitrogen molecule, first of all, you should understand that the formula will be N2 and the nitrogen-nitrogen bond is a triple bond. Okay. Then accordingly you write the electron dot structure and covalent bond formation. So this is the covalent bond formation in nitrogen molecule. Nitrogen-nitrogen bond is a triple bond. So one nitrogen as you know, atomic number is 7. So electron configuration 2 5. K shell will have 2 electrons, L shell will have 5 electrons. Out of the 5 electrons, the 3 electrons will be sharing with the next nitrogen atom. The second nitrogen is 3 electrons. The remaining 2 will be in this way. Okay. So this is the nitrogen-nitrogen bond formation, N2 molecule. Nitrogen-nitrogen bond is a triple covalent bond, N2. Next question. So this is our third question. What are isomers? Write the structures of two compounds having molecular formula C3H6O and give their names. Okay. So isomers, you already know that they have same chemical molecular formula but different arrangement of atoms. They are called isomers. And for explaining this C3H6, so what are the structures of two different compounds? So you should write two different compounds by using the same molecular formula. So our formula is C3H6O. So you can write 1, 2, 3 carbon straight and the fourth carbon will be at the end. And second possibility, you should write 3 carbon in this way and the oxygen you can give in the middle. So this oxygen, you should understand that this is a double bonded oxygen. Okay. Now you have to add hydrogen. CH3, CH2 and this will have one hydrogen. And for this structure CH3, CO. Middle carbon you don't want any hydrogen because it's a double bonded oxygen and there are 2 single bond also. Overall you have 4 bonds. So CH3, CO, CH3. So this is an aldehyde and this one is a ketone. So the first member is propanal and the second member is propanone. Okay. Now so this is the name propanal and propanone. Now the next question, what are soaps? How are they chemically different from detergents? So basically they are asking the difference between soaps and detergents. And the next question is, why do soaps not work effectively in hard water? Okay, this question is asked in 2023. Now we will look at the difference between soaps and detergents. Soaps are sodium or potassium salt of long chain fatty acids. Soaps are potassium or sodium salt of long chain fatty acids. But detergents are alkyl benzene sulfonate. Now, soaps do not work in hard water due to the formation of insoluble calcium or magnesium salt of fatty acid. Because hard water contains calcium and magnesium ions. So when you dissolve in this hard water, it will form some insoluble substances. Those insoluble substances are the precipitates of calcium and magnesium salt of this fatty acid. Okay. So this is the explanation is given. During the dissolution of soap in hard water, calcium and the magnesium ions displace sodium and potassium ions from the soap and form insoluble calcium or magnesium salt. That's why soap is not dissolving in hard water. Clear? Now, next question. It is observed that covalent compounds are bad conductors of electricity. Give reason. That's first question. Second one, carbon can neither form C4 plus cation nor C4 minus anion. Why? This means that carbon does not form any ionic bond. Why? Then draw electron dot structure of ethanol. Then you should identify the heteroatoms in the following compounds. Okay. So the first question is carbon. Carbon compounds are bad they're poor conductors of electricity. Okay. What is the reason? Usually carbon form covalent bonds. Now, since the electrons are shared between the atoms, no charged particles are formed here. Such covalent compounds are generally poor conductors of electricity. You already know for passing electricity, some kind of ions will be formed. But there is no ions formed in the case of covalent compound because the electrons are shared between atoms. So there is no charged particles are formed. So covalent compounds generally we say they are poor conductors of electricity. And the second question is why carbon form only covalent bond? Why it is not forming any ionic bond? So the detailed explanation is in the case of carbon, it has 4 electrons. You already know the outermost shell contain only 4 electrons. If it could gain 4 electrons, forming a C4 minus anion, okay. So what is the condition now? Inside the nucleus, carbon will have 6 protons, and the 6 proton has to hold 10 electrons. Okay, so that is not possible. Now the second condition, if it loses 4 electrons, forming a C4 minus C4 plus cation, it would require a large amount of energy to remove these 4 electrons. Okay, so leaving behind the carbon cation with the 6 protons in the nucleus holding on to just 2 electrons. So because of these reasons, carbon does not form any ionic bond. Rather than carbon forms only covalent bond. Okay. Now, next question. What is next question? Draw electron dot structure of ethanol. So for drawing this electron dot structures, you should know how the bonds are formed first. Ethanol you already know. Ethanol formula is CH3, CH2OH. Okay. I will do separately. CH3, CH2OH, ethanol. The structure is CH3, CH2OH. So this is the ethanol formula. Some of them will have a doubt like this is also ethanol, C2H5OH. Okay, now, so for writing the electron dot structure, you should write separately all the bonds. C, okay, there are 3 hydrogen here, CH3, now second carbon will have 2 hydrogen, then there is oxygen and there is 1 hydrogen. This is the main skeleton structure. Now you should put electrons accordingly. CH3, which means these are all single bond. So carbon around it will have 4 electrons. 1, 2, 3. This is the fourth one. Take the second one. 1, 2, 3, 4. Okay. Now this oxygen. Oxygen you have to draw only 2 electrons. Okay. And next you have to add hydrogen's electrons. 1, 2, 3, 4. This hydrogen will have an electron 6. Okay. This hydrogen's electron. Now when you draw the electron dot structure, you should check the octet condition is satisfied or not. So 2, here it is 4, 6 and this 2, 8. So this is the electron dot structure. Now, second carbon, okay, take these two electrons, okay, and for hydrogen, this is one. For this oxygen, the oxygen bond between a carbon and between this hydrogen is a single bond. Okay, as you know, oxygen's atomic number is oxygen has 6 electrons in the last shell. So we have explained here only two. Okay, the remaining 4 electrons, two will be here and two will be here. Okay, so these 2 electrons are not participating in this bond formation. So 2, 4 for oxygen, the bonding will be in this way. 2, 4, 6 and 8. So this is the electron node structure of ethanol. Now there is one more question. Identify the heteroatoms in the following compounds. What is one heteroatom? The atom which is forming a functional group, okay? It makes carbon with the different properties. So here the heteroatom is oxygen. That is oxygen. And here the heteroatom is chlorine. So these special atoms give special properties to carbon compounds. That's why they are called it as functional groups. Now, next question. Oh, that's the last question. Okay. So we'll see the next class with another set of questions. Thank you, children.